Quantities that can be measured are called physical quantities. Physical quantities include length, mass, time, temperature, etc. For example, when we measure the length of a cricket pitch using a measuring tape, or when a person measures the weight of a fruit using a digital scale, they are working with physical quantities. So any property of an object that we can measure is a physical quantity. Physical quantities are divided into two main types: fundamental quantities and derived quantities. Fundamental quantities are basic. There are only 7 of them. You might be already familiar with length, mass, and time. These quantities, the fundamental quantities, they are independent and cannot be broken down into anything simpler. We measure them using the SI system of units. Derived quantities are formed by combining two or more fundamental quantities. For example, speed is a derived quantity because it comes from dividing distance by time. So, fundamental quantities are the building blocks and derived quantities are built from them. Now let's take a closer look at the fundamental quantities and their corresponding SI units. These are the basic quantities we measure and each has its own unit. Length is measured in meters. Mass is measured in kilograms. Time is measured in seconds. Temperature is measured in Kelvin. Electric current is measured in amperes. Luminous intensity is measured in candelas. Amount of substance is measured in moles. Each physical quantity has a symbol that is used to represent it in equations. Here is a table summarizing the physical quantities, SI units, and their symbols. Now here is a piece of cloth. Imagine that this piece of cloth is 10 meters long. When we say that the length is 10 meters, what that really means is that the standard unit meter fits into the cloth's total length 10 times. So if we break down this length, it's like repeating the 1 meter length 10 times as shown here at the bottom. Each section represents 1 meter, and when we count them, we get the total length of 10 meters. This is a simple way of breaking down lengths using standard units. Now let's look at mass. Here we have a bag of sugar that weighs 5 kilograms. The standard unit we use for mass is kilogram. And in this case, the 5 kilograms means that the kilogram unit is repeated 5 times within the total mass of the sugar. To help visualize this, we can see 5 separate bowls of sugar, each containing 1 kilogram. When we add them together, we get the total mass of 5 kilograms as marked on the sugar bag. Just like with length, the kilogram is a standard unit and it is shown 5 times to represent the total mass of sugar. These examples help us understand how measurements work with standard units. Whether we are measuring length or mass, breaking things down into standard units helps us understand and compare different quantities more easily. Types of units we often work with: fundamental units and derived units. Fundamental units, as I described before, are the basic units that are independent of any other unit. Examples of fundamental units include mass, length, time, temperature, luminous intensity, electric current, amount of a substance. These are the core units that we start with when we talk about measurements. Derived units, on the other hand, depend on fundamental units. They are expressed in terms of fundamental units. For example, area, volume, speed, force, pressure, density, acceleration, all these are derived units because they are calculated from combinations of fundamental units like length and time. Now let's look at an example of derived unit in action. The area of a square is a derived unit. Area is found by multiplying the length by the length. If we write this mathematically, area of square is equal to length multiplied by length, or in terms of units, area is equal to meters multiplied by meters. Okay, so length is measured in meters. So meter multiplied by meters gives us meter squared. Similarly, volume of cube is another example of a derived unit. It's calculated by multiplying the length by itself 3 times. Length multiplied by length multiplied by length, resulting in a unit of meter cube. So as we can see, derived units come from combination of fundamental units, and they help us measure more complex quantities like area and volume. Speed is a physical quantity that tells us how fast or slow something is moving. The formula for speed is equal to distance divided by time. The unit for distance is meters and the unit for time is seconds. So the derived unit for speed is meters per second. This means that speed is measured in terms of how far something travels in 1 second. Meters per second. It is a derived unit which uses the fundamental units of length and time. Derived units are units that are formed by combining the basic or fundamental units of measurement like meters, seconds, and kilograms. Now let's look at a few common examples. Area. Area is calculated by multiplying length and breadth. So its derived unit is meter multiplied by meter, which gives us meter squared, symbolized as m squared. So that is meter squared. Then comes volume. Volume extends the concept of area by adding height. So it is length multiplied by breadth multiplied by height. That gives us meter multiplied by meter multiplied by meter, or cubic meter. Density. Density is defined as mass divided by volume. Mass is measured in kilograms and volume, as we just saw, is in cubic meters. So the derived unit becomes kilogram per meter cube, or kilogram per cubic meter. Speed is how fast something is moving, and it is defined as distance divided by time. Derived unit is meter per second. Acceleration is the change in speed divided by time. That means it's meter per second, or we can write it as meters per second squared. So, in summary, by combining fundamental units in different ways, we get new units called derived units. Before we end today's session, let's quickly recap what we have learned. First of all, we learned that quantities that can be measured are called fundamental quantities. These include length, mass, time, temperature, etc. Next, we saw that physical quantities are divided into two categories: fundamental quantities and derived quantities. Then, we discussed that physical quantities are measured using the SI system, which stands for International System of Units. This is a standard system used all over the world. The SI system is built on 7 fundamental quantities.
These are the basic building blocks from which other quantities are derived. Finally, we understood that any physical quantity that is defined using these fundamental quantities is called a derived quantity. Examples include area, volume, speed, and density.